talk on
wireless body area network.
like, so please start.
Thank you. Thank you, Dr. Bloomberg. Thank you, Temple and Genesis, for organizing my multi-hop trip from Australia. Okay, I'm going to talk about wireless body area network. You may be a little bit bored with my talk because after so many exciting talks, but I'll try to be more specific applications of the body area network. Now, this is the work of my colleague, Mehmet. Actually, he was supposed to be here, but he's getting married today, so I have to come here. Anyway, so what we heard yesterday about at the beginning of this conference about body area networks that various companies and various people are talking about wireless body area network. And what we are trying to do is to develop a low-cost body area network and perhaps use sort of hardware which can be used along with the commercial systems. So I'll talk about that, what are the different options currently available. And we're also looking at the multi-patient body monitoring system. So if in this same vicinity, either in the hospital or in the old home or wherever it is, that if we have to have multi-patient monitoring systems, so what sort of system we can develop. And we have got very limited measurement results because the permission to get these medical measurements is very difficult. Okay, so our idea is that the body area network, which is basically we transmit information from the body within 2 meters, and then we go beyond that, but the body area network itself consists of 2 meters, which includes monitoring of vital signs, medical conditions, healthcare issues, fitness. Now, we take another view, is that not only we use the telemetry system or body area network for monitoring, maybe we will be using these systems also for controlling the medical equipments maybe attached to the human body. Now, there are medical appliances which could be part of the body area network. There could be non-medical appliances which could be also part of body area network. For example, if a patient is not a critical patient, and if you want to see, say, some regular data, maybe a diabetic patient, then that patient information can be recorded, let's say, in the iPod instead of having a specialized equipment connected to that person. So we see that we can connect all these devices in a body area network, which may include medical and non-medical equipments. Now, many of you know that I'm a senior member of Communication Society, so we are involved in the Communication Society that, like yesterday Julian's work, you see that IEEE is developing a new standard for the body area network. So basically, this standard will be developed to satisfy the need of medical applications. Like you can see that the range will be limited between few centimeters to 2 meters. Extremely low power consumption, as we heard yesterday, that the power consumption is a big issue. The data rate, at the moment, we are talking up to 1 megabits per second, but there's an option of 10 megabits per second, and I'll show you later that we have developed some hardware which supports the high data rate. Now, there are other technical issues which I don't want to go through, but when we come to this scenario, this is our concept of body area network, that currently we got a system where the different sensors are connected via the wire to a control unit, and that control unit gets all the information from various sensors and transmit to another location via wireless medium, either Bluetooth or wireless LAN, which are commercial product available. Or we go to the other system, which is the true body area network, where the different sensors are placed on the body at different points, and they transmit, the sensor itself transmit via a very short-range wireless to a unit which connects and then transmit either to PDA or to computer or to internet, wherever it is. Now, the idea is that we want to develop a flexible systems where, like this CCO could be an iPhone, or could be PDA or cell phone, which may be able to send the data to via any of the standard communication medium we got. Like, for example, my cell phone can transmit the data, or we don't have to have a dedicated connection. So it makes a lot easier for people to use this sort of system. Now, another idea, as I mentioned, that some of them, some of the nodes here, or some of the objects here you can see, could be actually a medical device which might assist a patient. For example, if somebody has got a disability with that the brain information cannot be flowed to the other part of the body, then these objects can transmit those information to the right object here, so that the patient can get the brain information, as Kevin showed this morning, that brain information can be relayed to control other things. So this is basically the conceptual idea of a body network, and this also fits with the policy of or the objective of IEEE 802.15.6 standard. Now this is just a comparative review of the current commercially available and the medical frequency bands, which are which we have. Also, we have got ISM band, as you had, the 900 megahertz and 2.4 megahertz. But one of the things is that we are looking at concentrating on the new standard that comes up, and which we will be talking about 1 megabits per second data rate, and for a short distance. Now, another issue is that we heard yesterday that there are problems with the hitting of other unnecessary tissues when you transmit this information. So we may be looking at special design of antennas that you only transmit information to a very narrow specific path, so that you don't disturb other tissues or other organs. So, and also yesterday you probably heard that ZigBee standard being mentioned, which is extremely cheap, commercially available. So what we did is that we developed our hardware and tested this standard, and this is upcoming standard. We developed some hardware also, which is operating, and I will show you that how they worked. Okay, so this is a multi-patient body area networking, which we have designed that each patient can transmit their information to a controller unit, and then we can transmit this information to the right point. Either it could be your home wireless access point, Wi-Fi access point, or anything like that, and this information can go through internet. So this is the conceptual idea of our system, and then the information goes to the databases where the doctor can observe those things, or the action can be taken by the doctor to inform patients. Oh, another thing I forgot to mention, another advantage of the body area network is that we do also work on the wireless sensor network, that many buildings and environmental places, people are going to put sensor networks. Now, for example, if a patient is, let's say, has got asthmatic condition, and walking into an environment where maybe the pollution is high, then the other sensor network can inform that patient that, okay, you are walking in a condition where it may not be suitable for you. So it's basically intelligently interact with information with not necessarily only medical devices or medical doctors, with other environment where it can help the people to make the right selection. So this is a multi-patient hospital scenario, because we basically simulated the hospital scenario and did some testing that you got, say, for example, each room you got multiple patients sitting, staying there, and there are a number of such rooms adjacent to each other. And what we can do is that we can transmit information via these, from the sensor, via the multiple links to the either hospital computer or over internet or wherever it is. Now, what we did is that for testing, we used 2 different frequencies. As you can see that we use the MICS, the implant frequency, and we use the telemetry frequency. To transmit information, because we use 2 different frequencies so that they don't interfere each other. One of the issue is the hospital environment, that interference is a big problem. It might affect other instrumentation operation. As we can see that when we get into aircraft, we are always asked to switch off our mobile phone, although the mobile phone operates in a safe, different frequency than the aviation frequency, but still we have to switch off because out-of-band radiation could affect the aircraft instrumentation. So similarly, in the hospital environment, it could be quite sensitive that other instrument might be affected. Okay, now this is some of the actual hardware we developed in our labs, and our objective was to produce each of these sensor node not more than $40 or $50 cost. I mean, these are big boards, although these are for testing purpose, but if you do miniaturize, then they will be smaller. And we use the standard technology to transmit information, like we use the MICS band. So we produce the MICS hardware here, and then a telemetry band here to send to the base station. And what we did is that I'll skip this slide. I'll come to the result. This is our hardware. What we can do is that our hardware can actually observe 4 different parameters from a body. Each node can observe, or each object can observe 4 parameters, or can take data from 4 sensors and then transmit over the radio link to the next collecting station. So we have this system where the data could be recorded on the computer, or it could be sent to the PDAs so that the doctors or anyone can observe those data who wants those things. So this is just to show that we operate at a very low power level. Here is minus 12 dB power level, so that this is for the second link. And we got this operating. So if I go to this is our setup, which we did testing for ECG signal. So what we did is that we transmit this data over our university network. We don't have a special network. We transmit it over the university local area network. And our data server basically get all the information from the various sensors from the various patients. So if you go there, we can observe those data real time, say sitting on the computer or somewhere else. So the patient details will be, this is our patient record server, where all these informations are available, what is the patient data, and the real-time display can be seen, or we can observe later recorded data. Like this is 2 patients being monitored simultaneously. These are simulated data. Now this is the ECG data, which is being stored, again, got through the wireless sensor network. And those are being stored in the computer for later retrieval. So you can see that I think the data looks like pretty normal ECG data to me. Okay, then what we did is that we go to the multi-patient monitoring system, and what we did is that we actually use the Zigbee, which is commercially available, and 15.6 standard, which might come in 2 years or 3 years' time, will have some similarity to the current standard. So we actually simulated some of the standard and see that we observed that what will be the delay in getting the information from the sensor to the record server. For example, you can see that when the number of patients is increasing in the same location, the delay is increasing, because we basically need to have a device or mechanism to send patient data over the same link and not corrupting each other's data. So what we call is the multiple access mechanism. And as we can see that with the Zigbee, which is very cheap hardware, we can get reasonable number of patients in a single room, and where you can see that this is the sort of delay we might observe. Now, I don't know whether for observing critical patient, this sort of delay will be acceptable or not, but the delay looks like reasonably reasonably small. This is in millisecond delays. And again, we see that if we have got the same number of patients with the system in the same vicinity, then the data integrity, that how much data we might lose. If we have got a high number of patients, then we might lose some data with this very simple current hardware. Okay. Next thing what we did is that we developed the hardware for 10 megabits per second data rate, because like multi-ECG signal will require very high data rate link to transmit those data. Now, in this case, what we did is that we used the what we call as ultra-wideband system, that we have got a very, very wide frequency band. But within that frequency band, we transmit very high power pulse for a very short duration to transmit data at a very high data rate. And this is the standard the IEEE is looking at, that this ultra-wideband will be used for transmitting medical data. So we developed the hardware, and I'll just go to see that this is the sort of ECG signal we got in the lab. And what we did is that we intentionally corrupted the ECG signal with 50 hertz noise. That's the power line noise, because in many applications, the power line signal is interfering with the other signal. And in our system, we filter out that signal, but somehow this fourth graph is not showing that the actual ECG signal. We've been able to remove those noise and get the actual signal back. So this is one of the few, I think, hardware, the ultra-wideband hardware, which has been developed complying these body area networks guidelines to transmit data at a high rate. So this is the clean data we get using the ultra-wideband hardware. So basically, we present our view that there are many systems where the single parameters of a patient can be observed through these either dedicated link or specialized link. But we are developing systems or hardware which will be flexible enough that it can interact with standard hardware. As I said, that for example, my iPhone could be, or PDA could be a mechanism which will collect data, and either the data will be transmitted over the either internet or the cell phone line, or you can take the iPhone or iPod to the doctor and say, okay, read the data from there, and produce a cheaper system to monitor patient, as well as that we see that in future, the medical instrumentation will be a lot more advanced, so for example, doctor looks at your data and say, okay, I probably need to adjust the pacemaker, or I need to adjust something else, and those information can come back from the doctor's computer, and those devices can be set or reset or retuned in that way. So this is the sort of things I think we are looking at developing. So thank you.
Do we have some questions?
Hey, Julian Penders, Host Center IMEC. I have a quick question regarding the network. So you show a demonstration or a prototype where you deploy the different hardware sensor nodes in the hospital. Of course, you generate a lot of amount of data and vital signs or vital data. So there is a need to address the topic of security and privacy of that data.
Yes.
I was wondering what was your opinion and the approach that you see for these
Yeah,
issues?
obviously patient data is need to be very secure. We haven't looked into that, but what we did is that each of these nodes have got hardware address assigned to them, and they are mapped onto their TCP addresses there. So there's a bit of security there because we can control those addresses there. But the privacy and security of the data issues we haven't looked at yet.
In your opinion, is that addressed in the 15.6 standard or not?
I don't think 15.6 is going beyond MAC layer. It's because its security is probably left to some other people to look into that issue.
Are there some further questions? No, thank you very much.
Okay, thank you.